Here I'm going to show you how to name these alcohols from McMurray Chapter 13, number 26, parts D and E. Again, this is the second edition with biological applications. First, you want to identify the longest chain that contains the hydroxyl group. When you have a ring, they must all be in a cycle, not including side groups. Six-membered rings, like benzene, have 6 carbons. This has 5, but you want to identify the longest ring that contains the hydroxyl group. So it would be this cyclic 5-membered ring, or cyclohexane. Okay. When you number the carbons, you want to choose the lower numbering if possible. So numbering the alcohol carbon 1 is what you want to do here, because the alcohol receives priority. You want to number in a clockwise position to position the methyl group at carbon 2. Coming over here, this would be carbon 1, and we would want to number counterclockwise to position this phenyl ring at carbon 3. Okay, so the name of this is going to be, without the stereochemistry, first of all, it's going to be a methyl group at carbon 2. Okay, there's a methyl group at carbon 2. There's an alkene at between carbons 4 and 5. So remember, the alkene numbering uses the first of those numbers. So we have an alkene at carbon 4. And this is a 7-membered ring, which is cyclohexane. So when you assemble the name here, it's going to become 2-methyl cyclo hept 4-ene for the alcohol, the alkene. And this is a vowel here that's going to clash with the all, so we don't use the E here. And then the alcohol is at carbon 1. Okay. When you have two different functional groups in the same ring, like an alkene and an alcohol, you need to use a numbering for where the alcohol is. So the full name here is 2-methyl cyclohept 4-ene 1-ol. Now, there's a stereogenic center at carbon 1 and 2. So over here, we're going to have 1 R or S, carbon 2 R or S, and that's going to be in parentheses. So we need to figure out, do we put an RS here or an RS here to describe the configuration at carbon 1 or carbon 2. So when you look at this molecule here, perhaps it's best if we draw a new diagram, since we have numbers already drawn on our molecule. Let's just take a look at the alcohol carbon, which is carbon 1. All right, so let's consider the stereogenic center here at this carbon. Okay, we rank the priorities of groups based on the atomic number, or atomic mass. So here, hydrogen is the lightest, oxygen is the heaviest. Okay, so that's substituent priority 1 and 4. Now we have carbon and carbon, which both tie. Okay. So when you have a tie, you go out further. This carbon has a methyl, a hydrogen, and a carbon. So it's got a carbon, and a hydrogen bonded to it. Carbon, carbon, hydrogen. This has a carbon and a hydrogen and a hydrogen. Okay, so you go through the ties until you break the tie. Carbon and carbon, okay, this has one more carbon attached to it than that. So this substituent on the right, which is part of the ring, is priority 2, and this carbon here is priority 3. All right, the lightest substituent is pointing back, so we just basically look to see if we're going in a clockwise fashion. Clockwise, think about a car turning right, is R. So in the name here, we would put 1R. Okay? So for carbon 2, we have to do the same kind of analysis. Again, this is a messy diagram here, so we'll go ahead and redraw it. Doesn't really matter about the wedges and dashes here, but I'll redraw the molecule exactly as it originally appeared. And we've got our methyl coming out towards us and a hydrogen. So again, the lightest substituent is going back, which is nice. So that's priority 4. Okay? And here we have a three-way tie. Okay, again, we're looking at this stereogenic carbon. So I'll call this group A, this group B, and this group C. And we'll just look at a runoff table here. Okay, for the first competition, you can kind of think there's a carbon, carbon, carbon attached to each branch. Okay, so it's a three-way tie, so we need to break that tie. So again, let's look at carbon A. As we move out from the stereogenic center, there's 3 hydrogens here. So there's H, H, H. For branch B, we've got 2 hydrogens and a carbon. So list them out from heaviest to lightest. C, then those 2 H's. And then branch C, we have a carbon. I'm not going to write a C because it looks like a C here. You have a carbon, an oxygen, and a hydrogen. So write those out from heaviest to lightest. Oxygen, carbon, and hydrogen. Okay, so now you can see oxygen wins. So that's priority 1. So C is priority 1. Carbon is better than hydrogen, or heavier, so branch B is priority 2. And the methyl group just has 3 hydrogens attached to it, so that's branch A that has priority 3. Okay. Hydrogen is still the lightest, so that's priority 4. Again, we kind of drive the car and see which way we're turning. We're turning left, okay, counterclockwise, that's S. Okay. So the full name for this would be 1R, 2S, then the 2-methylcycloheptadene, 1-ol. All right. Over here with part E, we have an alcohol at carbon 1, right? So, and a substituent at carbon 3. That substituent is called a phenyl group. Okay, so the name of this without the stereochemistry. Again, we have a stereogenic center at carbon 1. We'll figure out what that is. And carbon 3, we have a stereogenic center there. And this is a phenyl group at carbon 3. So if you see the benzene ring or the phenyl ring or pH, that's all the same thing for phenyl. So this is 3-phenyl. Cyclopentanol. Okay. Now, I'm choosing not to use a number 1 here to describe where the alcohol is, because technically there's just one, functional group in the ring, and we're naming this as a substituent. The phenyl group is, of course, an aromatic functional group, but it's just positioned at carbon 3 like a methyl group or something else. So I'm just going to say cyclopentanol. Carbon 1 is assumed to be where the alcohol is attached. So let's go ahead and figure out what the stereochemistry of these are. This hopefully would be a little bit easier to figure out. Let's work on the carbon 1 again. So the alcohol has the highest priority because of the oxygen atom, and this hydrogen has priority 4. And then we go out and we keep seeing who breaks the tie. So there's a carbon, so that ties. Go out further, there's a CH2, and then there's C, right? So carbon 3 here, this part of the ring has higher priority, so that's going to be priority 2, and this is going to be priority 3. So when you ride the car here, it looks like you're going counterclockwise. So 1 to 2 to 3 to 1, it looks like you're turning left, so we say that's S. Okay, so 1 is S. Yes, diagram's getting really cluttered, so let's draw it down here and figure out what the other configuration is at that other carbon. So we got the phenyl ring. And I'm going to draw this out so we can take a look at the situation with the ties and the carbon atoms, okay, and saying which one has priority. So again, we're looking at carbon 3, and we're trying to figure out what the priority is here, so we can assign this as RS in the name. So hydrogen's going back, and we've got carbon versus carbon versus carbon. So again, it's a three-way tie. I'll just call the phenyl group A, the top part of this ring B, and this chain C. And let me make a ranking table here and just see what comes out. So group A is bonded to this carbon here we're looking at, where my cursor is located, is bonded to 1, 2, 3 carbons. Remember, a double bond is counted as 2 carbons. B is a CH2, and C is a CH2. All right, so B and C are now in tied. We now have a winner here for the group, so this whole group here is priority 1. Okay, so B and C we're looking at CH2. We go out one more, so let's look at this carbon and compare that carbon. So this carbon is bonded to oxygen, carbon, and what we have here attached to this carbon is an oxygen, carbon, hydrogen. And to this carbon, we just have a CH2 again. So we can see how oxygen, since it's higher in atomic mass, outweighs the carbon. So chain B, which is up here, has priority 2. And chain C here is priority 3. And again, we drive the car figuring out which way the rotation goes. So carbon 1, group 1 to 2 to 3 to 1 appears to be right or clockwise. So the full name here would be 1S, 3R, 3-phenyl cyclopentanol. So these are rather complicated, but I thought I'd take you through it nice and slow. Thanks for watching.